Assalamu alaikum students. Today we will talk about acid, bases and salt. So first MCQ is, all of the following statements are not correct except. So we have to find the correct statement in these options. Okay. The value of base dissociation constant is low for strong bases. So look here, Kb is directly proportional to strength of bases. Okay. So it means that when base is stronger, then the Kb will be higher. So this one is wrong. Look at the B option. The value of acid dissociation constant is high for weak acid. Now Ka is also directly proportional to the strength of acid. Okay, strength of acid. So it means that stronger acid will have higher value of Ka. Look at the C option. A strong acid has low pH and a pKa value. So this one is correct. Okay, this one is wrong. Look at here. Ka is directly proportional to strength of acid and Kb is directly proportional to strength of base. Here pH is inversely proportional to strength of acid. So a strong acid will have low value of pH. And look at the C option. A strong acid have low pH. Okay. Now look at the pKa value. pKa value is inversely proportional to strength of acid. So it means that stronger acid will have low pKa value. So a strong acid have low pH and pKa value. So here C option is correct. Look at the D. The value of pKb is low for weak bases. Now pKb is inversely proportional to the strength of base, which means that weak bases will have high value of pKb. So this one is also wrong. Now look at the second hydroxyl ion donor are. Now look, it is hydrogen. Okay, hydrogen ion donor are arsenous acid. We have studied that in arsenous acid the statement is like hydrogen ion donor are arsenous acid and hydroxyl ion donor are arsenous base. So here option C is correct. C, the third number. Conjugate base of a strong acid is weak. Now listen. Here we know that Ka multiply Kb is equal to Kw. Okay, this is an equation in your book. Okay, this is the relation between the Ka and Kb. So we can also write it like Ka is equal to Kw divided by Kb. If we take this one as constant, now look at here. Ka is inversely proportional to Kb. What does it mean? That a strong acid, we know that strength is directly proportional to Ka. So greater Ka mean a strong acid. A strong acid will have weak conjugate base. Okay, a strong acid will have weak conjugate base. Now look at here, conjugate base of a strong acid is weak. So this is the relation between conjugate acid base. Okay, look at the fourth one. Lewis bases are. Now in Lewis bases we have studied that electron pair donor are Lewis bases and electron deficient molecule are Lewis acid. Okay, so Lewis bases are electron pair donor. Next one. Consider the following reaction. HCl plus NH3 gives Cl negative and NH4 positive. The reaction is, now look at here, what happened? This HCl, here is HCl and this hydrogen, this proton is given to NH3. Okay, so here it become NH4. So here the acid has donated the proton to the base. Okay, acid donated proton to the base. Now look at the options. A Lewis acid base reaction, Bronsted acid base reaction, arsenous acid base reaction in general. Now look at here, it's Bronsted acid base reaction. In Lewis acid we talk about the electron pair. Okay, electron pair. In Bronsted acid bases we talk about the proton. Okay, we talk about proton. And in arsenous acid base we talk about hydrogen ion and hydroxyl ion. Okay, so here a proton is donated to the NH3, so this equation is Bronsted acid base reaction. Now look at the sixth one. The strength of an acid and base is its ability to. Now we have studied that the strength of an acid and base depend upon the hydrogen and hydroxyl ion. Okay, production of hydrogen and hydroxyl ion. So look at the D option, it's correct. Produce hydrogen and hydroxyl ion. A strong acid will produce greater amount of hydrogen as compared to a weak acid. A strong base will produce greater amount of hydroxyl ion as compared to a weak base. Now look at the 7. A weak acid has a peculiar smell. Look at here option C. This one is correct, high pKa value. We know that pKa is inversely proportional to the strength of acid. Okay, strength of acid. So it means that a weak acid will have high pKa value. And look at the B, high density. So a weak acid mostly have low density. Okay, and look at this one, weak conjugate base. So a weak acid has strong conjugate base. And look at the A option, peculiar smell. So it doesn't depend. Okay, Now 8 number. Acetate ion CH3COO is a. Now look at here. What is acetate ion? Acetate ion come from CH3 C double bond OH, which is a weak acid. Okay, it is a weak acid. So it means that this ion will be conjugate base of this acid. Okay, and we know that a conjugate base of weak acid is stronger. Now look at here, strong conjugate base. Okay, here acetate ion came from weak acid. Okay, so we know that when it lost one hydrogen, so what happened here? Only acetate ion will remain and it will act as a base. Okay, we know that it came from weak acid, so it will be a stronger conjugate base. Ionic product of water is, now ionic product Kw, it depends upon the temperature. Okay, so look at here, difficult to tell without knowing temperature. Now this one option is correct, because here the temperature is not mentioned, but we only know that at room temperature it is this one. But in MCQ they have not given that whether ionic product of water at room temperature or another temperature. So it is difficult to tell without knowing the temperature of ionic product. Kw only depend upon the temperature. Okay, so we can't predict what will be the Kw value without temperature. Now look at the 10th. Ionic product of water upon dissolving an acidic salt like copper sulfate is in it. So I told you that Kw only depend upon temperature. Okay, it's like Kc. We know that Kc only changes with temperature. So like here in case of water, Kw only changes with temperature. So acid or base will not affect its value. Okay, so it will remain unaffected. pH values of two solutions A and B are 3 and 5 respectively. The value of pH shows that. Now what is the value of pH shows what? We know that the strength of acid depends upon the concentration of hydrogen. Let's find first its concentration. Here is the formula to find the concentration. Now look at here. In order to find the concentration of A, look, 10 power minus pH. You have to put the value of pH here. So it will become 10 power minus 3. Okay. Now look at here. The pH, the hydrogen ion concentration of B. Look, 10 power minus 5. Okay. Now look here. We know that this one 10 power minus 3 is 100 times greater than this 10 power minus 5. Okay, this 10 power minus 3 is 100 times greater than 10 power minus 5. Like you can prove it, 10 power minus 3 is equal to 100 times of 10 power minus 5. So you will get this one answer. It means that 10 power minus 3 is 100 times of 10 power minus 5. This one is 100 times greater than 10 power minus 5. Okay, now look at the D option. Solution A is 100 times more acidic than solution B. So this one is correct answer. Okay, look, pH 3 and pH 5. So it means that this one is 100 times more acidic than solution B. Or you can also find it like this. We know that pH is inversely proportional to acidity. Okay, when the acid is strong, what happens when acid is strong? Then its pH is lower. Okay, like the strong, like we have two acid 5 and 3 having pH 5 and 3. We know that this one acid is more, this one solution is more acidic as compared to this one. Okay, so when the acidity increases, the pH decreases. Now how you will find the times, okay, that how many times it will be greater. Now keep one thing in your mind, that when pH increases 1 unit, what will happen? The acidity will decreases 10 times. Okay, when the pH increases 2 units, the acidity will decreases 100 units. Okay, 100 times the acidity will decreases 100 times. Now if it were 3, then it will decreases 1000 times. Okay, you have to put 0, you have to add 0 with this. Okay, with 1 unit acidity will decreases 10 times. With 2 units the acidity will decreases 100 times. With 3 units the acidity will decreases 1000 times. Now look at here. This one is greater 2 units, like 5 minus 3 is equal to 2. It means that pH is 2 units greater. Okay, the pH of this one is 2 units greater than this one. So it means that the pH will be 100 times smaller. This pH will be, acidity will be 100 times smaller than this one. Okay, now look, solution A is 100 times more acidic than solution B, because solution A is 2 units smaller than solution B. That's why its acidity is 100 times greater than solution B. Now look at the next MCQ. pOH of 0.001 molar HCl solution is. Now here we know that given is HCl, so first we have to find the pH. Okay, the given is HCl acid, so we have to find the pH. pH is equal to negative log of hydrogen ion concentration. So here hydrogen ion can be written like 10 power minus 3, okay. Now this minus will cancel this one, it will be 3, the power will come with log, okay. Now log 10 is equal to 1, so the pH will be equal to 3. Now we know that pH plus pOH is equal to 14, so pOH is equal to 14 minus 3, which give 11 answer. So here the pOH is 11. Now look at the next one. If molar concentration of hydrogen ion in aqueous solution at room temperature is this one, okay, what will be the molar concentration of hydroxyl ion in the solution? Now here look, we know that hydrogen ion multiply hydroxyl ion is equal to 10 power minus 14, okay, this one is the equation. Now look, here the required is hydroxyl ion. So we know that hydrogen ion is 10 power minus 4, so bring it in division here, so you will get 10 power minus 10 hydroxyl ion concentration. So here option B is correct. Now look at the next one. Acid dissociation constant for an acid is, so here we know that Ka is equal to H3O positive, A negative, H divided by acid, so this one is the answer. 15. Base dissociation constant is high for. Now look at here, we know that Kb is directly proportional to the strength of base. So when Kb is high, it means that the base strength of base will be high. It means that the option D is correct. Base dissociation constant will be high for strong bases. Look at the 16 one. Acid dissociation constant of an acid is the ratio of. Now look at here, we know that Ka multiply Kb is equal to Kw, okay? So you will get Ka is equal to Kw divided by Kb. Now look, it is the ratio between ionic product of water divided by base dissociation constant. Now here option B is correct. Acid dissociation constant of an acid is the ratio of ionic product of water to the base dissociation constant of an acid, okay. So option B is correct. We know that hydrogen ion concentration multiply hydroxyl ion concentration is equal to 10 power minus 14, which is Kw, okay. And we also know that pH plus pOH is equal to 14, which is pKw. Now look at here. We know that when pH is equal to pOH, that one is the neutral point of a solution. Now in which case the pH will be equal to pOH. Here, when pH is equal to 7 and pOH is also equal to 7, then it means that the solution is neutral. Now look at here. When the pH is equal to 7, at that point the solution is neutral. Okay, neutral. But look at the MCQ. The ionic product of water at a hypothetical temperature T. Here the temperature is different. This one is at room temperature, okay, room temperature. But the temperature is different and it give ionic product of water 10 power minus 12, okay. Like if I put here 10 power minus 12, then what will be the neutral point? In that case, when pH is equal to pOH, here the neutral point will be 6 is equal to 6, okay. When it become pH is equal to 6, then it will be neutral point of the solution, okay. Now they have given that a solution with a pH 7. Now if the solution has a pH 7, in that case, now look, in that case, if the solution has pH 7, then what will it mean? It means that the solution is basic, okay. When the pH is greater than 6, greater than neutral point, then it means that the solution is basic. When pH is 7, the solution is basic in this case, okay. In this case the solution is basic. Now look at the options. Here option B is correct, the solution is basic, okay, because here 10 power minus 12 is written. So when we have this number, then the pH will be 6 and this 6 will be neutral point, okay. When we have this one, then it will give pH 6 and it will be neutral point. And above 6, when the pH is 7, then it will be basic point, okay. The solution will be basic at that time. The pH of pure water increases with temperature, decreases with temperature, and do not depend on the temperature. Now look, pH is inversely proportional to temperature, okay. When we increases the temperature, the pH will decreases. Now look, pH of pure water decreases with temperature, okay. So this one is correct. pH of pure water decreases with temperature. However, the hydrogen ion concentration is directly proportional to temperature. Now, when the pH decreases, we know that at that time the hydrogen ions are increases in the water. A solvent can affect the strength of an acid. Which one among the following is the strongest acid in aqueous solution? Now look at here, we have to find the strongest acid in aqueous solution. So the first method is that, let's suppose we have three components, and acid is made up of three components like this: AX, B, and CY. Okay, this one is acid. Now what? And subtract X from it. Okay, and subtract X from it. Then this value will be directly proportional to the acidity. Okay, the strength of acid. So this value will be directly proportional to acidity. Now look at here. A, C, and D are made of three components. Now apply this method. 4 minus 1 give 3. 4 minus 2 give 2. And 3 minus 1 give 2. So it means that these two are cancelled. Okay. Now we have to find in these two that which one is the stronger acid in A and B. Now look at here. The next method is what? Oxidation. Oxidation state is directly proportional to what? Acidity. Oxidation state of central atom. Okay, central atom is directly proportional to acidity. Now we know that here Cl is negative and H is positive. Let's find the Cl. Okay, the oxidation state of Cl. Now look at here. We know that hydrogen is 1 plus, we have to find the Cl. So Cl plus what? 4 into minus 2. Now look at here. 1 plus Cl, and it is equal to 0. Now it will give minus 8. When I brought this here, when I bring this here, it will be 8. Okay. Now Cl is equal to 8 minus 1 is equal to 7. Now look at here. The oxidation state of Cl is 7. It means that this one oxidation state is greater. So here option A is correct. Okay. Here option A is the strongest acid of all these. 20. A buffer solution of acetic acid and sodium acetate contain. Now look at here. A buffer solution is made up of weak acid plus strong base. Okay. Now when these react, what will happen? Sodium acetate will form plus water will form. Now here what you have to do is you have to take this weak component in buffer solution. You have to take the weak component in large amount. Okay. Like I will take this in 3:1. Okay. I will take this 3:1. Now this 1 ratio will react with this one. Okay. Now the ratio of this one will be 1. Okay. Now what will happen? This NaOH will react with this one and it will be finished. Okay. It will be finished. Now in solution, what will be present? This one will be present. Okay. CH3C double bond OH will be present, and this will be finished. Okay. And CH3C double O and a sodium acetate will be present in a solution, plus water will be present. Okay. Water will be present in solution. Now look at here. We know that a buffer solution is present in this form. Okay. A buffer solution is present in a solution in this form, like CH3C double bond OH, and it is present like ion forms. Okay. And this salt is also present in ion form. Now look at here. A buffer solution contain which one? These ions, these one. Okay. And look, this water will react with this one and it will form H3O. Okay. H3O positive. Now we have 4 components present in a solution. Look at the options. Option D, CH3C double bond OH. Okay. CH3C double bond O. Look here. And H3O plus Na. Okay. So here option D is correct. A buffer solution of acetic acid and sodium acetate will contain these 4 components. Okay. They will be formed either in ion forms or in this one form. Okay. But they are present in solution like this. Okay. So option D is correct here. 21. A salt of weak acid and weak base. We know that act like a buffer. We know that a weak acid and a weak base, when combined with a strong acid or strong base, then it will form a salt. Okay. Now a salt along with weak acid will act as a buffer. Look at 22. In what ratio should we mix 0.1 molar solution of sodium acetate and acetic acid to produce a buffer of pH 5? The pKa value of acetic acid is given like 4.74. Okay. Now look at here. This one is the example present in your book on page 225. Okay. This one is the example on page 225. So here the option B is correct. Is incorrect. Only this one is in 1.82:1. So this is the ratio of acetic acid and sodium acetate. Now look at here. We will solve it like pH is equal to, for acidic buffer, this one is the formula. pH is equal to pKa plus log salt divided by acid. Okay. Now here the pH value is 5 and pKa value is 4.74 plus log. Now bring this here and it will become 5 minus 4.74. Now it will give 0.26. Now bring this log here, so it will become anti-log. When we bring this log on the another side of the equation, then it become anti-log. By taking anti-log of 0.26, it will give 1.82. Now 1.82 divided by 1. I can also write it like this. So the ratio will be 1.82 ratio 1. This one is present in your book on page 225. You can also learn it from here, okay? So here the answer is option B, 1.82 ratio 1. 23. Which one among the following salt solution will turn blue litmus paper to red? Okay, so it means that acetic salt will turn the litmus paper into red. Okay, now what is acetic salt? Acetic salt is made of strong acid plus weak base. Okay, it is made up of strong acid plus weak base. This salt is called acetic salt. Now look at here, the sodium bicarbonate is made up of NaOH plus H2CO3. Okay, now look, this one is strong base and this one is weak base. It means that this one is option A is incorrect because it is basic salt, and basic salt do not turn the litmus paper into red. Now look at here, potassium nitrate solution. Now this one is made up of KOH plus HNO3. Okay, so KOH is a strong base and this one is weak acid. So it means that potassium nitrate solution is also basic salt, okay, and it will not turn the litmus paper into red. Look at the copper sulfate. Copper sulfate is made up of CuOH2 plus H2SO4, okay. Now look, H2SO4 is a strong acid, okay, and this one is weak base. So it means that this one is correct. Copper sulfate solution is acetic salt, okay, this one is acetic salt, so it will turn the litmus paper into red. Look at the D option, sodium acetate. It is made up of CH3, C double bond OH plus what? NaOH. Okay, so the base is strong, acid is weak. It means that this one is also basic salt. So this will not turn the litmus paper into red. Only copper sulfate solution will turn the litmus paper into red. So here option B is correct. So this one was the last MCQ of acid, bases and salt. If you have any problem regarding any MCQ, then write in the comment section and subscribe my channel. Allah Hafiz.